Health stream is healthy. Good. Back here. Feel free to say hi. Let's figure out what's going on. Did I not save that number? I thought I changed that number. Video. What? Didn't change the bit rate. Huh. Oh well. I will try to save the bitrate change. Hopefully this bitrate works for you. Hello. Mosne 1, 2, 3. Hello. We're all working good. Hello. Okay. We're probably just going to sit on this slide for a few minutes while I give a quick overview of what we're going to do. So today, we're going to try to go from the block diagram to the platform, or block diagram, AIE, insertion, platform, export to Vitis. Vitis generates AIE engine, or compile AIE engine. Vitis connect it to platform integration, export that upgraded platform, and then have the processor drive the AIE engine, and then send that PDI file to the Versal, and then see the output. So we're gonna try to do that from beginning to end. I was going to try the demo on Windows and Linux. The system seems to work best on Linux. So we're going to be just doing a Linux demonstration of the AIE-MLs. And we're going to be doing the simple tutorial that is located on their website. And then we're going to go through all their other tutorials and learn the ins and outs of getting this up and running. Okay. I'm looking for. What's a good I guess, does anyone have availability to a Versal? I don't think there's any. There's might be some Versal cloud services. I should probably look at that. That might be affordable, the best affordable option. To try to find a cloud service. Hey, Quaint. We could try to find a cloud service that provides affordable time with Versal. The dev boards should be coming out. We should start seeing AVNet and dev board coming out, and hopefully that's a good price range. Didn't like the AVNet one so much. I need to find a good dev board. I guess I could get the AVNet SOM or I should pick a SOM. I should do a carrier card. Oh, designing a carrier card would be hard, but I should try to design a carrier card. Okay, so we are going to dive into this. So first, we're going to talk a little bit about what we're going to target. So we're going to be looking at the AIE engines on the Versal AI Edge. These are their generation with integrated memory, and we'll point that out in a second. So the AIE engines are accessible through the NOC or through an AXI PL stream here. So you can go through the NOC or directly to the programmable logic. They do need to be configured. And previously, I feel like that configuration code was a compiled binary, so you weren't able to see it. There is now code. There's some code to help us understand. I think Xilinx is trying to make, or AMD Xilinx is trying to make it more open. Well, Xilinx is trying to make it open. I'm sure how AMD will be affected in the future, but we're going to try to look at how one of the A72s configures it over the NOC and sends data either through a PL stream or through, we're going to do the PL stream today, and then tomorrow, or no, not tomorrow, later next week, we'll look at doing a NOC data stream in and out to the AIE engines. So looking at the documentations for the AIE engines, this right here is actually a really good example of what we have in our system. We have 2 rows of AIE-ML tiles, which have the processor, 64K of memory, and some DMA interconnection. Then we have memory tile, which is, basically the same thing, but a lot more memory. This is great for machine learning, where you have a lot of coefficients or variables, or um, um, a lot more computations you need for your convolutional neural networks. And then there's, here's the PL stream tile, here's the NOC interface tile, and then these connect to the memory tiles, which then go to the AIE tiles. So let me pull up exactly what that looks like in our device. So this is what we're going to build. I'll walk through in a second. Stefan? Thanks, Stefan. I try to do raw streams where it's basically unedited cut of how you go through these tools, and I feel like that is super useful yet super boring, and I try to make it as entertaining as possible, and hopefully people can come in and talk as we go through this process and help people who really need to resolve the issues from or even walk along if you got the hardware or something like that. You could operate with the video to actually see someone take all the necessary steps to accomplish something. Okay, we have some ZU102s and pink boards in our lab. Yeah, the Versal AI Edge should be coming out Q2. I mean, it's already Q2. We'll say Q3, and they should be affordable. Okay, so this is what the array looks like in the tool, and we'll talk later about how we understand this a little bit better. So here is the PL stream input and the PL stream output, and here we can even zoom in into all the little routing blocks. So here's the interconnect, and this is it going up through the memory through this array, and then it goes to this processor. So these, I guess these are instances, kernel instances that are put into this processor. What is this over here? Sysmem. Oh, interesting. And then while this is your executing processor, you're actually using instruction memory up here. So we can actually see what space the instruction memory is taking in the different locations. So this gets really cool when you start having, multiple streams, multiple processors. You can, diverge and merge and split streams. It can get really interesting. We're going to be doing some simple models, and then we're going to build up and do some more complex models and actually run these on the system. Okay, so let's go back here. We're going to go, if you want to follow along with this tutorial, I'm going to try to follow it as close as possible. We're going to accomplish the tutorial, and then we're going to start digging into playing around with some of the code, some of the features, see if we can get some settings. But this does take a long time, and we'll probably spend about 2 hours just trying to get this tutorial up and running. I don't know how much time we're going to have to explore it, but we will try to walk through it so you can follow along without issue. So we're going to go to the AIE development. Since we're on the AI Edge, we're going to look at the AIE-ML section. We're going to go to the feature tutorials, and then we're going to go to the AIE A to Z. This is just kind of getting something base set up. And it says it's going to, it wants us to go to the other example. So we're just going to jump to this example and use a custom platform. They suggest, using an example project. We're going to do one from scratch. I want to show you how you can do this from scratch. So we want to get to this export platform step. So we're going to go to our custom board right here. So this is the project we did last week. We have our Versal, and we have just the SIPs, which is your processor, your NOC, and your DDR controller. So let's go ahead and set this up so we can get this platform ready for AI development. So the easiest thing, easiest thing is we want AI. We're going to get an AI engine. and we're going to run a connection automation. This will just hook it up to the NOC. And you'll be like, hey, I want to do Axie Stream. I want to add more NOC interfaces. You click this, you get nothing. Vitis is what adds that, not Vivado. So I'll show you where it's added later. It's actually really cool. We can actually watch the block diagram being developed. But right now, this is all you do. You just pop it in and connect it to the NOC. That's all you need to do for your first step. Now we're going to add an interrupt controller. This will allow us to have allow the Vitis platform management system to be able to add interrupts when wanted. So we're going to go ahead and open up our PS side. And we want to go to PS PMC, pull up the interfaces. We're going to activate the full power Axie bus. We're going to activate the first interrupt. We're going to hit OK. We're going to finish. Okay. Now we're going to add, interrupt controller. We're going to, well, first connect the clock there, connect that interrupt there, and then we're going to just do the automation for everything else. And that should bring us all good. Okay, and then we can just bring the reset there, and that should disappear. Now we're going to validate it. We're going to, okay, so now we don't have a platform design. So this is, well, let's look at the NOC and then we'll talk about the platform portion. Ooh. I'm going to talk fast, but I want you to make sure if you miss anything, make me repeat it, maybe talk slower, maybe explain more. I'm probably just going to talk as fast as I normally talk, which might be a problem in itself. But make me keep everyone up to date. Okay, so this is the AI engine interface we added to the NOC. So we can see that there's a total of 12 interfaces, 6 masters, 6 slaves. We'll need to go in and update that. And then we have, oh, did I not remove that earlier? Where's that one coming? Oh, did it really connect? It connected that. I wanted it to there, and it connected it there. Oh, well, I guess it still appears on the NOC address space. That's a funny place to put it. Where is it? Right here. The SIPs NOC. Sure, we'll put it there. I was hoping to do it there, but that works just fine. Okay, so we want to upgrade this system to a platform. So we're going to go to Edit, and we're going to go to make this an extensible platform setup. Hit OK. Now we have a platform setup tab. We're going to do 2 masters on the Smart Connect. We're going to do 2 slaves. But we're not going to do MIG on these. We're going to do high performance. And this is a tag if you want to go to a high performance port instead of a MIG port. For the NOC, we'll just let it be general purpose, and we'll do 2 MIGs. The clock, we're going to enable, make it default, interrupt, enable, platform name, top view 1, export. And it wants us to generate the design. So if we go to Flow Navigator, we're going to generate the block diagram. Okay. So let's set up a new workshop. So we're going to go and open a workshop. And we're going to go here, and we're going to create a new one. Call it simple this time. All right, okay. So we're going to open up a blank project. Okay. We'll let this generate. We'll kind of skip a step. I'll show you how to finalize the export in a second, but let's imagine I've already exported the design correctly. So we're in our workshop. We're going to go to create platform component. We're going to call it platform. We're going to keep all the names default here to make it simple. Go to hardware design. We're going to go base AIE top V1. I'm going to go next. It looks like if you want to get the AIE-MLs working, you need to be running Vivado and Vitis on a Linux platform. The Windows do not have the examples built in as expected. Drink on my wine. Oh well. Okay. So now, operating system, we're going to switch to AIE runtime. This is automatically going to switch the processor to AIE engine. We hit next, we hit finish. We've now created a platform for developing an application for the AIE engines. And then we are just going to click build, and let's just populate our libraries. Right, that's red. Just, are there any problems? No, you're not. Okay. Yeah, it looks like everything worked as expected. So now we're going to go to examples, AIE examples, installed AIE examples. We're just going to do a simple one. We create it from a template called simple. So we're going to do simple inside of simple. Okay, yeah. Click the platform we just built, and we're going to finish. Okay, so now we're now going to build the AIE simulator. Simple includes sources, data. To do. So this is building. One thing, if you have an issue during the build, I had this issue where I had a assembler include file on Linux was not being found. I just need to create a symbolic link to the folder in Ubuntu where it's called ASME generic and not ASM. So if you do see airno.h, this is Ubuntu 20, I think, maybe 22. I think it's 20. So this is a quick fix for that. Okay. Going to have to. Okay. Any questions? Any discussion? Feel free to post something in the chat. We're going to try to do this in a way where you can follow along with all the different configurations and possible errors and troubleshooting. So there may be some awkward pauses. Okay. While that finishes, we can show platform setup. Okay, so when you export the platform, which we already used with the other thing, we're going to do hardware and hardware emulation. We're going to do pre-synthesis for now. The post implementation is actually useful if you want to define the routing, like say you already have a good external static design for your interfaces or your PCIe, and you want to lock down the routing for that, and then use the dynamic function exchange for kind of the interior portion of AIE engines. This is probably the method that they use for any type of data center card as well. We're going to pre-synthesis and let V++ have full access. And then we're just going to, generate the XSA. Oh, that was caps locks. Whatever. That's going to bother me. Okay. And that's how we get our design prepared for Vitis. And then we can open up Vitis and target the XSA file. Okay. So now that we built it, we can go look at the graph. And it's just going to take a simple input, and we have a first and a second. So let's go look at this, right? So we have the kernels, and the simple is defined here, and we go to think it's kernels.cc. And the simple is just adding the real and imaginary for the real, and then doing the real minus imaginary for the imaginary portion of the output. What did they describe this as? Okay, yeah, so that's really all they're doing. And then if we go to project.cpp, we have two graphs. Where are these graphs defined? Okay, this is the important thing. We have the inputs. So this is probably the most critical portion of your AIE map. This creates all your different interfaces and your kernels. This is kind of like the top level for your AIE kernels. So they have the output input PLIO, which is fabric IO axis stream, and the output PLIO. They made two kernels with the simple, and basically they're just connecting the in to the first to the second, and the second to the out. And looks like they're defining the dimensions here. Where's num samples come from? And they have the source here and the ratio of operation. Oh, these are happening in the same processor, I think. Yeah, I need to go learn these a little bit more. Dimensions, 32 samples. Yeah, I'm going to learn about this a little bit more. Does this have the definition? This is so useful. Oh, the dimensions of the input and the output? Is that what it's doing? Okay, it's defining the dimension. So it's gonna be 32 bits in, 32 bits out. Did this not define it? Okay, maybe you bring in, oh, are those num samples? Okay, here, it's just bringing in the num of samples. Okay, so it wants to do 32 16-bit inputs and outputs through the system at a time. And the runtime, the ratio. Is there any good information on this? Yeah, you should probably go look that up and understand it a little bit better at some point. Okay, so we have the graph here, and then we can look at the array. And this is what we were looking at earlier, where we have, so this is the ratio, right? Where it's 0.1%, so it's 1/10 of the processor is focusing on this and focusing on this. So it probably has just some type of loop where it's going back and forth. It's kind of interesting. We don't log mapping analysis. Okay. Anything terrible, special there. DMA analysis. Block allocation. Nope. Kernel guided. I got nothing. AIE compilation. Okay, nothing useful there. So let's go ahead and run it. So we're going to run a hardware simulation for our processors, and it's going to be running Project CPP. So if we go to Project CPP, we're going to run it for 4 iterations. And it's basically taking the simple graph the simple graph right here. And I don't know what it actually means by run for 4. Did they say that in the tutorial? No, they don't. Okay, so now that we run it, if we go to output, simulator output data, we get this output, and we get a timestamp and the values, and we can go compare this to our golden values. Split right. So we can compare our output do our golden and see that if we remove the timestamps, we would see the correct value. Is this okay? Are we having a system error here? Well, it looks like it's happy. Let's see. Ooh, this is fun. I'm going to kill this and reopen it. Okay. Jobs. We have it here. No, we don't have it. Vitis IDE is a big. Vitis IDE is 195. 195 691. Okay. We still have some more Vitis IDE. Okay, here. Okay, I'm just gonna kill it in the task manager. Cool. I have lost my mouse. Okay. Try to get my mouse back real quick. Okay, there we go. It processes. Where are we going? Still. Okay, is there anything else worth killing at the moment? Okay. Okay. Let's open up Vitis. That was slightly annoying. Okay. Cool. We're back up and running. Any comments, chat? Nothing? Okay. So we're gonna go back and open simple one. Then we're going to do system integration now. We have tutorial or the AIE, it works, whatnot. Okay. We're going to open anyways. Okay, so now it wants us to modify the project CPP to run this only when okay, we'll copy it from here. They want us to system, no, we want to go here, PL creation. Copy this, bring it here. Oh, it's probably Linux and it's not system. There we go. Save that, and now we're going to add PL kernels. Okay, so we're going to go to a file. We're going to go to new component. We're going to do HLS components for these are going to be DMA components. We're going to do memory map to stream. Next, we are going to do an empty file. Click next. Configuration. 'Keep the default settings and click next. no, we're in the we're gonna add the file to the source folder. Do I need a? I'll probably just create a new one and copy it in. I don't have it right now. We'll have to copy it in a second. Okay, so we're gonna hit next. On platform, we're gonna be our platform. We want to do Vitis kernel flow, and we want to generate a Vitis XO. Next. Okay, now we're going to create a file here. New source file. We're going to call it mm2 stream. That's C. Okay, then we're going to go into the Vitis source. In source right here. And we're going to copy. Okay. And we're going to go to the JSON configuration. Okay. Where's the top function? We're going to search for the top function, and we should find that. Perfect. Cool. So we've added it. And now we're going to do it for the other system as well. Okay. So now we're going to go file, new component HLS. We're going to go stream to memory map. We're going to do empty file, HLS config. We're going to fill that out later. Go to our existing platform. We're going to do a kernel flow and have an XO file. Okay. Okay, then we're going to go here, sources. We're going to add new source file, go into P. Copy this. Save it. Okay. And then we got to go settings, let's config, browse the top function, hit OK. Okay, so now we need to okay, now it wants us to create a new system project. We're gonna go file, new component, system project. Yeah. I'm gonna call it simple project or system project. I don't feel like changing it. We're gonna select the collect platform. We are going to skip the embedded information because we're using bare metal. I'm gonna hit next and finish. Okay, now it wants us to go to the sys.json right here, right? Okay, and we want to go to components, add existing HLS. Okay. Add existing HLS. Okay. Add existing AI engine. Yes. Okay. We've added the components. Now you need to tell the compiler the connectivity. This is done as a configuration still in the settings under the hardware link settings. Under the hardware linker settings, click on binary container 1. And here we have the link file. Oh, this is nicer. This is way nicer. Sheesh. Okay. Okay. The kernel data. Can I add things? I want to connect them. You're not gonna let me connect things. Okay. Yeah, we want to export that. I'll do that now. Okay, now you want me to click here and the connectivity. we're going to add these lines. Okay, so we're going back to the Vitis tutorial. Okay, sorry I haven't been like helping you guys follow along with the tutorial, but feel free to pull up the web page. It should be in the description. This will help you okay, stream connect. Save that. Okay, and then let's see, does this pop up here? No, I don't. Which they need to add a little connectivity here thing. It'd be beautiful. Like just click and drag. Be great. Okay. So now we are going to build the binary container and we're gonna watch it. So if we're gonna watch it, let's pull up Vivado real quick. So here, let's pull up the Vivado. I want to show you guys how it's going to build the system. Okay. Hey Nick, glad you in the chat. Follow along on our journey to get AIE working. Okay, here it is. We'll open the project in a second. So if we go back to Vitis, we are going to look at hardware and we're going to go to the link stage and we're going to build the binary container. And hit OK. So once it gets to the Vivado stage, we can look at how it changes out things. Hopefully it doesn't take too long. Hopefully my Steam Deck is... Oh yeah, this is all running on Steam Deck. My little hardware platform. Development platform. Okay. So while HLS runs, any questions about how to use them, why to use them? You don't want to have Versal, you just want a giant FPGA opinions, anything to discuss as we wait for Xilinx to do something. Maybe I need just some hot takes. Should we go look at some crazy FPGA news? Okay, you're opening Vivado. Still doing HLS. Okay. Where's that wonderful? I want to check on the. I want to check on the Ice Cube situation. Apparently, Lattice added a subscription for some of their hardware, and I want to check up on that. Discuss some FPGA news. Okay, not here. Let's go back here. Open up a new tab. Ice Cube 2 no longer free. Oh. Okay. How are we doing here? Okay, we're actually doing the AIE compiler right now. We haven't got to the fun part where it's actually connecting and executing things. Okay, let's see. So we're no longer free. Russell with Nanland and his Ice Cube open source, or not, his Ice Cube example board of his recent book. I think it was only like, what, 6 months ago that his book came out? Where did I put that book? It's over there. So he lost the tool chain for his book, which is really sad. Do we have any other news besides that? Okay. Yeah, it doesn't look like we have any new information. See if I can look at any recents. Can we sort this by recent? Sort by new. Okay, nothing terribly new. But some interesting FPGA news. We'll see if anything comes out of it. Okay, what are we doing now? Okay, so did we get the link? Okay, we're running link. That's great. So it's gonna run link. So once it runs link, okay, here we go. This is where it's doing the whole thing. It's connecting. Stop moving. I'm gonna show people things. Okay, we have this connectivity, and it's inferring argument to HP. I wish it inferred to MIG. Oh well. So it's probably going to connect it to the Smart Connect. Ooh, did they do it wrong? Maybe I did the whole. I might have to redo this. It's gonna be so annoying. You did it. You were so close. Yeah. Okay. So deck. And file build hardware. The XSA file should have that DCP, right? I don't want to do this all from scratch again. Platform. Okay. Is there a way we can... We go here. Do we have a way to update emulation XSA? Switch XSA. Okay, we're gonna try to switch the XSA. Let's go. Let's go do this. Let's go fix this. Okay, so in this situation, we put things onto the smart controller, but the issue is the smart controller does not have access to the memory. And I guess we could change the connectivity to go to the MIG. Anyway, can we change that real quick? To do connectivity. Uh-oh. Did we break you again? We broke it again. Makes me angry. Okay. Let's go kill the Vitis. 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 Kill. Kill. Okay. So the issue is it was trying to use the Smart Connect, but the Smart Connect is not connected to anything. So, well, first off, I'm going to let me review the picture real quick. Where's the picture on this step? I'm gonna make sure I am doing this correctly. Okay, yeah. First off, this is only the AIE, so go into the knock. I want to drop this down to 1. And the connectivity is good. AIE, okay. Hit okay here. And we're gonna take this here. I think it's all running off the same clock. Yeah. Validate it real quick. Yes. Go auto assign it. I'm fine. Ugh. Yeah, stupid. Don't just erase it. Unassign that address. And okay, that is better. Now you're on the correct memory map for the system. Okay. Let's see if this works. Okay, so when we go to platform setup, we're going to remove everything related to the Smart Connect. It has access to nothing. We only want to use the knock. So we're going to export this platform. We need to generate outputs. Yay. Ah. Was trying to make a versatile example design. Did not turn out too well. We need to go look at how to use these tags and how to effectively use the connectivity, because this connectivity is like really cool, because if you have like multiple streams, multiple systems, data flow going to different places, you can have V++ or Vitis be able to connect all your kernels and your AI engines together, kind of at software level. Maybe if they had some better GUI tools, it'd be more effective, but it is a cool idea. I like it. It's kind of like it's another level of this upper level block diagram routing planning that's more inducive to a software based design flow, and which can be effective for like data center deployment. But the tools are still early in their uses. Also, might be good to get a better performing system. I mean, the Steam Deck does a pretty good job getting all these things built. Doing up all these. It shouldn't take too long to do these things. They're mostly just hardware designs. Okay, let's see how many unique people have joined in. We have 18 unique people, which is kind of slow. Yeah, I need to post these so people can follow along better. Okay. So you're happy with this, even though those are still running. But they finished, I guess. Hardware emulation, post synthesis, copy two, copy two. Guess maybe it's still waiting for the runs to finish. Kind of weird I let you do that early. Okay. While we're running, I guess I should probably say this every like 30 minutes or something. We have a Discord. Feel free to join the Discord. We can ask more direct questions, more direct examples. Feel free to like, follow, subscribe, help share this with people who will be interested. Hopefully, just Google search and YouTube search or anything like that will guide people to this process. Okay, so we're going to go open Vitis again. Hopefully, it doesn't kill at us. Vitis, especially for the AIE-MLs, is like technically we're in beta. Technically, this is all beta release of the software. So don't expect it to be perfect. Hopefully, the new release will be more stable, have some more utility to it, and be such a big issue. We're going to try to change our XSA file. We're going to build the platform and then build okay, so we're gonna go to platform settings here. We're gonna say switch. I'm gonna go V2. And it's gonna update it. And as soon as it's done updating. Okay. That's fine. We're gonna build it. And then we're gonna build the system, hardware, build binary container. Those should all be built already. We're just trying to do the linker portion. And right now, we should just have the MIG option for the system. Okay, running link. Okay. Don't go HPE, go MIG, please. Okay, connectivity. Okay, yeah, right here, right here. We have inferred mapping it to the MIG. So now it's going to go through the NOC, not through the Smart Connect. Oh, good. See if we can finish this in like 50 minutes. Still failed. What are we failing on? It says the top wrapper TCP does not exist. Okay, let us explore this. That is weird. Okay. I mean, it says that I couldn't find that. I guess we'll just go ahead and open that project. I feel like it got built with the other system. Why is this one having issues? I love debugging issues. Hardware link. No, we want to build hardware link, container, binary container, bravado, PL. I don't know, backup one. We want the project. There we go. So you're saying, yes, you're saying that the top wrapper TCP. Why is top wrapper DCP not? You're not importing it properly? Any warnings earlier? Did I go look at the other AIE-1 design? Maybe. Try to figure out why this one's failing and that one isn't failing. Maybe we could maybe switch to it, see if that does anything new. Okay, I mean, I see it here, the project. Good. Yes, we can go check out the Vivado log as well. Didn't modify this at all. Okay, so this is the error. Can assign slave register. Didn't we fix that? Why do you think that? It's a bad proposed address. Unassign. We have to reassign it. Okay. We're gonna switch it one more time. So let me go. We're gonna look at AIE-1. We'll come back to here in a second. Don't save. Okay, looks like this was a stupid issue where the incorrect address was saved in the XSA. I'm going to see if we can use this other XSA file. Okay, I don't know how to, I don't want to fix that real quick by building everything. So we're going to go AIE-1 and grab that top wrapper. And we're going to make sure it looks correct in a second. I just want to demo something. Oh. Hopefully this has the correct configuration on. I have to go check it in a second. A platform, build that. Okay. So this pops up soon so we can look at it. Why do you have JESD in this one? I'm concerned. Okay. This is what I expect. I just want to double check the DDR thing here. We can just probably use this one. Connectivity. It's the DDR add DDR memory and efficiency. That's what we wanted. Platform setup. Okay. So I think we just okay. So this all works. Let's try assigning and reassigning that address again. I'm afraid this one won't link properly. Well, we can fix the other one while this one goes on a journey. Okay, so let's go back here. We're going to try to get that address working correctly, but we're going to head and try to do go back to the system project. Wish we could do this step by step. Okay, you run, if you work. I want to go here and try to get the address. I'm kind of confused why the address failed on us. So right here, see, it popped up again. I opened it. So let's go address editor. I guess we're going to, how about we unassign all, and then we're going to assign all. Save it. And clear. Okay, we're gonna generate it, close it, open it. See if that changes anything. Okay, so it's working on this one. What interface did you do? Okay, they connected to LPDDR. That's good. So we could probably use this one. We'll build the other one later to make sure it works. It was a silly bug. Ugh. Okay. Validation successful. We're going to generate the block diagram. Let's reduce the jobs to 2. I want you to mess with the other system down here. Okay. Um, hmm. Okay. I kind of want to go back and look at that connectivity thing in the platform settings. It wasn't here, right? For link, configure link. Here. All right, this is running in the generate step. We say yeah, I need to look up the connectivity. There's ways you infer where these memories are connected to. Can't remember where. But the tool is building as expected. This one's Okay, are we done here? So if I close this, get to close the block, reopen it, I want to see if it has that little magical error at the bottom. Then we're going to export it. Then we're going to show I don't see an issue. Okay, we'll try this once again. We just care about those. We're gonna export this. 3. 3. Now we're gonna open up this other project that's building so we can look at what the design is doing. I'm running 4 jobs, okay. Oh, we're gonna run into swaps soon. Not good. Anything else here I can do to close this? This. Okay. Hopefully that helps a little with memory. Okay, let's go check it out. Okay, so we're gonna go look at what the program is doing with that other one. So down the rabbit hole we go. Yeah, close. Okay. Hopefully we have the UART correct on the other one. Guess I could configure it otherwise. Okay, so if we open up the block diagram, we can look at what's happening. Oh, we had a question about how does this differ from the DPU? That's a good question. So the DPU is tied directly to Vitis AI, and Vitis AI is kind of a different beast. Vitis AI it's much more software flow focused. It doesn't like the V++ integration is very similar to the DPU, but how does that work with like it's a kernel, so it kind of you can then like drop in things, connect things to it, kind of like you can with the AIE engines. The DPU is just going to be it. I haven't played with a DPU on Versal Tech. On the ZCU 102 and whatnot, you have a soft system, and you're basically loading AI and whatnot into it. And I believe it's kind of a soft version of these other systems. Okay, we want to look at this. So, Bravado is slowed right now. Okay, my one job running would be. Should we be able to look at this? Or not double click this? So, pop open this. We have the AIE engine. It magically populates an AXI stream port. So this is different. So this is V++. Yeah, but I haven't played with Vitis AI and the Versal. How does Vitis AI insert the AIE engines for the Versal? Because there was a planned porting from the DPU to AIE engines. So they have to have it must be like a soft version of the AI engines or some type of like the configuration operation of those two systems should be very similar. Okay, but yeah, V++ added these actually stream ports. We have an additional smart connect here, and okay, that's for control. Where's this control going to? Is that going to the knock? Yeah, it's going to the knock. I only gave it the knock to do that stuff on. And then we have these memory ports, which are going into the knock itself. How's the knock look in this situation? So these must be the two data ports. Are they completely separate? It gave them one each. Okay, independent knock packets. Okay, so we can probably get some nice speed on that. Okay, we're not worrying about that. And then we have those systems. Okay, who has access? So you add it there, it looks like, and the AIE engine is there. Okay. Where are we? We are in synth design. This is going to take a long time to potentially watch. Okay, synth design is done. It's going to automatically run into implementation, so we're not even going to worry about that. But we can follow the implementation. Not started yet. Okay. Hopefully I didn't screw up by trying to look at it. Uh-oh. I wonder if I screwed it up. One thing to consider. Okay. Let's close it for now, and hopefully that I could close. Where there was a command to close project. Am I crazy? File. Close block design. Sure. If I want to close the project, oh, I have to go into project. Okay. Close. Ah, then that gives us to the whole little default menu. I can exit that one. Runs. Okay, it's. Oh no, it's running it. Usually you can see. Maybe it just needs to update it. Let's see. Do I need to like close the project and come back in? If it's magically working on it. Okay, cool. It is just magically working on it now. Log, implementation. I don't know if it's going to take much longer. We're probably going to have to continue this another day, where we actually look at running it on the processor. Well, that's probably good. What are we at time wise? So we're at an hour. I mean, this is probably a long enough video in itself. So the next stream, we're going to then take this platform and get it working on the processor and be able to run the AIE software from the application processor. Okay. Any questions before we turn off the stream for the day, and then we continue this next time? Okay, we had a question. We're here. Is the Steam Deck beefy enough for this? Yes. There is a few configurations. going to the compiler. The only thing I had to change for the Steam Deck was in the AIE compiler config. If we go down to the ELF options, there's like an ELF. Where's the ELF options? ELF generator. You want to put in a J2 or J3, and the Steam Deck worked fine. The big issue is when you start doing multi-threaded AIE compiling, it starts using 8 gigabytes per thread. Let's see. I have a good picture of this. Anyways, you'll easily go out of swap space if you don't do like a J2 or a J3 in the ELF generator. So just like adding, I don't want to add it right now because I don't want it to reset everything, but you have to do like a dash J2 or dash J3 to limit the threads on the Steam Deck. And then it works great. Ugh. But yeah, Steam Deck is surprisingly very effective at Vivado and Vitis. I think the high-speed DDR LPDDR4 at 5200 mega or 5200 mega transactions does a really good job. I tried to play around with the external, but my external hard drive did not like the Steam Deck, so this is all just using the internal 512 gigabytes of memory on the Steam Deck. It'd be nice if we could upgrade to like 32 gigs of DDR. I think I've seen videos of people do that, but yeah, if you can find a like a Steam Deck or Ally or MSI, is it Legion? Legion Go, MSI Ally. If you can find one with 32 gig variant up in like the 50,000 mega transaction, it worked pretty well. Okay, can you explain why does the hardware in this what does the hardware do in this platform? The block diagram. Okay, yeah, we can go pop in at the block diagram. Okay. Let's do a block diagram review before the night ends. Okay. Okay, we have the block diagram. Do this over here. So the block diagram, we originally added the SIPs, the knock, and the AIE engine, the reset. We added all of these things. So the SIPs, the control interface and processing system. This has this is basically your bring up embedded processors, which are microplaces. This has your real-time processors. This has your application processors, and this configures the processor I/O. So if you like want any UARTs or you want any like SPI, I2C buses, eMMCs, USB, PCIe, some other of those interfaces that are kind of like dedicated. Well, the PCIe is not dedicated to the PCIe is on the NOC, but a lot of the interfaces dedicated to the processor exist in the SIPs. There's a lot of configuration that goes through that. Next, we have the NOC. So the NOC here is a representation of this bus. And these are the master ports and these are the slave ports. And the NOC is kind of simplifies that large network with single or multiple blocks that you can change it. And the NOC also contains the DDR controller. So this is where you specify DDR4 or LPDDR4, and then you get these external buses. Oh, look at it. Did it really finish? Oh, we might get to the processor today. I'm excited. And this configures to the system. Okay. Build finished successfully. Wheat. Let's go. I have energy. I have passion. Let's go finish this up. Okay. It built correctly. So the instructions say we're going to do a new platform. And we're going to call this a new name. We're going to call it platform A to Z. And we're going to do hardware design. What we're going to do is we're going to go into the binary container of the system project. Right? Am I going to build hardware link binary container? Okay. So we're going to pick the binary container. Oh. Yeah. Is this a little bit better? Okay, that's still populating. Okay, so we talked about the knock. We have an interrupt controller. We have a smart connect, which is an interconnect between different AXI buses. The reset block just helps times the resets for positive and negative asserted or low asserted, high asserted resets. We have the AIE engines, which will open the implemented design, which are really cool. We can look at how those are connected. And then we have HLS DMA cores, which are just doing data transfers between the AIE engine over AXI stream to the DDR pins here, over to DDR. I'm going to open the implemented design so we can see what that looks like. Let's go back here. We're going to do standalone processor. Yes. Hopefully this works. I'm going to do a quick configuration before we build it so we can see the output. Okay, that should be fine. So before we build this, I want to do a quick change here. Yeah, going to be board support package. We're going to do a quick change so we can get some output. Standalone. Right here. Oh, this is standalone. Where I want to change. Okay, here. We're going to do core site. That's what I wanted to do. Core site. Okay. Save that. We're going to build the platform. Ugh. Implement design. Okay, cool. Let's highlight the DMA engines. It's going to be in the Vitis region. With DMA engines. Highlight yellow. Weird. Expect to see them. Digging too much into the FPGA. Do I need to like highlight leaf children? Okay, cool. So those are DMA engines. This is and then this is where the PL connects up here into. I'm curious what the AI engine primitive looks like. Okay, we're gonna find it. The parameters. PL AI wrapper. Where is the special name for it? I want to find the primitive for it. Maybe it's a net? I don't think it's a net. It wouldn't be a net. It'd be a red slice. We looked at red slice. It might be here. Not there. Shim. This is probably not useful right now. So I want to see where. Okay, here. We found the primitive. Beautiful. Where's this primitive? Is it right there? This is the primitive. Okay, here is our primitive, our AI-PL channel of the AXI data. Is it actually connected to it? Oh, it's actually connected to it. Okay, cool. This is where we connect to the AI. Okay, so we're in. We built the platform. Now we're going to do an application. A to Z software. Yeah, next. We're going to do platform A to Z. We're going to do standalone processor. Yes, yes, yes. And we're finished. And okay, here we go. Now in sources, it wants us to oh, look at you are where are we going? We're all on the knock 0. Okay, we're all going to DDR. I'm fine with that. So we're gonna import file, and they want us to import a file from the build here. There's apparently a where's it under? Work. Apparently there is a PS control system. You want AI control CPP. What's that JSON? Okay, we're gonna go look at the JSON. I'm gonna go hunt at that JSON real quick. Output, work, yes, control. What's a JSON do? Tell me the JSONs. AI metadata. Ooh, this should be in hex. This it bothers me. The graph, the rows. Okay, so this is the configuration, so you can check that out anytime. Okay, back to processor land. So we have an AIE control, a bunch of defines, setting up the system, configuring it, and setting up controls for running. Now we're going to do a new file and call it main.cpp. And now we're going to copy the file here. Right here. Copy that. We got. Okay, so I got a lot. Inputting data, outputting data, size. So it's mallocing it, which is nice. Okay. Let us build it. What are you angry at? Okay, sure. Build. Xyl prenf. Use sleep. Use sleep. Did that not come in the X parameter file? Ooh. This is not running out of the box. Okay, we need to add the include boxes. Okay. Under the app user, open user config cmake. User config cmake. You want me to add in the directory section, add item. Okay. You want me to add this? Never mind. Back here. We're gonna add paste. Oh, got it. Ah, we're gonna be writing it by hand, I guess. Oh, it's gonna be workspace, simple. What's just simple AI in this situation? Okay, so that's gonna be simple, I guess, in source. Okay, add item. We're gonna do environment links or Vitis. AIE tools. To do in. Okay. I guess I could browse for these items if really necessary. Build. Okay. Did we not find these? Okay. Yeah, there's sources there. Let's browse for this one. I think we want to go source. Yeah, where we want to go. I'll browse for that one, I guess. That's going to be computers, tools, Xilinx, this AIE tools, include. Okay, so now those are direct. Okay, build. Okay, what are we missing up here? XI engine. Are you not? Why are you not getting the includes? Why are you not? Do you not have any includes? Okay. We're gonna delete this. Yeah, angry at it. We're going to try step by step with hello world. And maybe this will provide the appropriate includes because it doesn't seem to have any includes in that example, which is annoying. Okay, cool. Hello world includes. Look at that. So many more includes. So excited. Okay, so we're gonna build this and we're gonna run it. And I want to see hello world on it. Okay. Run. How do we we have to go to the system, do that. Before didn't we just hit local hardware app? We set program device, enable cross triggering. Yeah, looks good. Run it. I think it said hello. Okay. It's building properly now. Okay, so hello world C. Okay, so let's import that one file again. You happy now? Okay, you can go find that one. Let's go here. We're gonna add those items again. Yeah, that one. And browse. We're gonna go head back up to where we are currently working. And okay. So those are included. ADF. Okay. Need to find that file. Okay, let us go hunt. I like hunting. XFP, AIE-ML. Okay, we're gonna find here dash name. We're looking for AIE pro config.h. Okay, so and then we want to do this tools Xilinx Vitis. Let's just make sure it's not in AIE tools anywhere. Okay, so it's there. So if we go here, there should be an ADF folder. No, not that folder. Here, the AIE tools include as an ADF. That ADF API has a control figure H. So it's there, I promise. Build. Why did you break? Why did you try to do J22? That's silly. Why would you try J22? Undefined. Come here. So we have undefined reference to okay, undefined reference to initial configurations. Oh, I don't want to look for this. Why are you not working? Okay. Line 293. Okay, this might be in our area. So we're here. We're gonna cd into simple. Oh, cd simple. We're gonna grep for configuration. Initialize configuration. Initialize. 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 Okay, we have the CPP file. And do we need to reference those? Looks like we need to include the XRT CPP file as well. So let's do that. Maybe we need to import that file, XRTC file. Okay, build. Why did we fail this time? Undefined reference. Did we not solve the problem? What line is it on? It's on. Oh, that's just its use case. Okay. So let me see. If we go jump down to simple and we go here, we're going to line 295. 295. You know where you are coming from. You're coming from ADF, so definition. The definition found. So I guess we need to find this in tools. Vitis silence. The joys of running beta stuff. I guess we'll try AIE tools first. You're defined there. Are you not? Yeah, it's definition. Okay. Maybe it's not in the C file. Okay, let's start at the top. Undefined reference. Okay, we don't probably need that file. Multi-reference is simple. Okay, so I guess we'll remove it from there. Delete for now. Okay. That's all I'm getting. Let's see if Google helps us. I don't know why the copy is not working over recording at the moment. ADF, lies big the silence. There's something else we're missing in steps. Oh, we have to add the library. Okay. Me not reading the instructions all the way through. Okay, in directories, we add that in libraries section. The library section too. Libraries. We want to add item ADF API. Okay. Add item. Same. Just grab the path for the AIE tools include. Yeah, edit. Thank you. Okay. Do my copy act. And build. Oh, it's still not happy. Okay, we need to fix the linker script. I can do that. I can do that. Linker script. I want a heap size of this big. Who's still with me? You can't find a library? Really? Oh. Okay. I see. I did the library thing wrong. I'm going to edit this. It's going to be lib, and we're going to grab arch none 64.0. Okay. Who's still watching? We built it. Okay, now let's bring in that main file again. Oh no, though, but my copy feature was not working. Also, we'll have to get the JTAG terminal up and running. Uh-oh. The copy feature is not working at the moment. I may have to. Oh, great. What's the best way to get this going? I guess to reopen it. So let's exit, close this real quick. Try reopening that. Yeah, I mean, there's errors, and then there's just me not following identical instructions. Looks like they want another 0 for their heap size. Ugh. Okay. I have to do UART. Maybe UART would be more interesting. I do want to make sure the UART is correct on that configuration. Go back here real quick. Oh, we're running this on this side. Okay, we're gonna go back to simple. Yeah. Tell me with the UART pin on this one. Okay, yeah, open it anyways. We're in hello world. We're gonna try to copy the I don't wanna Okay, I guess we're just gonna have to copy that file. Yeah, you can even download that file, please. And then we're gonna go here and drop it in. Okay, we're gonna go to AIE-ML, simple, hello world, source, and we're going to just drag and drop. Try it again. Drag and drop. Do you just appear there? Yes, you just appear there. So we're just going to delete you for now. And build. Okay, we built. Okay, I guess we can try to run it and see if the outputs come up. Otherwise, I'll try to set up XSDB. XSDB connect. Oh, it also wanted the heap to be massive. I might have to rebuild it for the massive heap. Okay. To targets. We're gonna target 6, and we're gonna need to get the screen, was it? Yeah, JTAG terminal. Okay. Restart. Are you running? I have to do screen instead. Well, let's just verify the UART is what we expect. Okay, UART 0 is on IO 34, 35. And let's go double check the other one. Recent. Okay, if it's not on those two, we're gonna have a issue. See what happens if we're going to turn off the system. No, it's gonna get angry at us. Okay, let's try. Oh no, we want to fix the stack real quick. They want another 0, I think, there in the stack. We're gonna rebuild it, rerun it. Okay. Yeah, X11 copy and paste is not working. Yeah, annoying. Are you? I don't know where you are. Okay. Are you not running the whole system? Breakpoint. Uh, you didn't tell me where you debugged. Stop. Okay. Did any find out here? Okay, let's try this again. Okay. Okay, let's get a screen going. Well, first, that opening. What's the best way? Because they suggest going into. I guess we could try to run this. They suggest going into Vitis JSON here, and under package settings, we want to click this guy, and then we want to go to bare metal elf. And that is the most annoying thing in the world. I have to do this by hand. Apparently that's going to get us hello world. And we have to do /build, and is there a build directory here? I don't see a build directory here. Just see an elf file. How did you get It doesn't make sense. Is there a build directory there? Okay. This real quick. Go and explore this AIE tools, AIE-ML, simple. I'm gonna go to hello world. Is there a build? Yeah, we're gonna go to build and ls. So it wants saying there is a hello world. The hello world elf file. It wants a A70. Oh, okay. It wants that. So it's gonna be hello world elf, comma A720. So that's the one it's going to. That is nasty, but whatever. Okay. So now we're gonna go to AIE engines and okay. Yeah, we'll do that. And they don't want us to do. Okay. Now we're gonna go down to system project, hardware, build all. Okay. Now we hit run. Run. Create a configuration. Hardware. Target connection. I guess so. Should be local. Run. Trying to run it on a system. Okay, I do not want to do an SD card. What running the system? I want to run it over JTAG. Why do you think I have to? We want local. Okay, we're gonna call it local 127.0.0.1. Okay, local. Cool. Try it running it one more time. More and more errors. Okay, I don't know what to do next. I want to verify that UART's correct, and then I'm going to set it up for hello world. Okay, UART, IO. The UART's correct. So let's go ahead and just set up a screen. We're going to go to platform, setting, no, output, no. Where am I going? Right here? Yep. forward support package, let it populate. We're going to go standard in, standard out, and get a screen going. Yeah, I am going to do this because it's going to work. So we're going to build this. And we're going to set up ls dev UI USB 1. Might have to like hit a go screen 15200. That going. Yeah, kill that. Power cycle. Screen might not like that. But we can do it real quick. Okay, hello world. So let's go to the configuration for this, shall we? Oh no, we already ran it. Too late. Okay, yeah, we're gonna do the cool. Running. Versal, no, cannot reset Versal. I will reset the Versal for you. I have to. Let's kill this. I've had issues doing that. I think I'm fine. Oh, I want it to work. Yeah. I want you to generate an SD card. So stupid. I just want to run the L file over the PDI file. Maybe I have to go select new generated PDI file. There's the output, packaging. We just have these. But if we go to hello world, let's see. Is there food image, simple? Okay. They're like build. And this is the XSA file we already exported. Hardware link. Under output is build hardware package. Looking for file, PI file, style bins. Okay, that's so useful. Been running. Get the screen going. What do you mean? First off, where's a terminal? Where's my output? Targets. Okay, I see them. No more lying to me. Maybe I need to do a different USB. Dev UI USB. We should be seeing this main start. Okay, we want to see this. See that somewhere. Okay, it's running. That got kicked. Curious. We turn this on. We got there. Okay. Do our USB. The other one going. Might as well just try to get Hello World working again. Screen. Dev. By USB 3. 5. Okay. Make sure we have them all figured out. Dev ls pgy 1 2 3. Okay. Run. Yes, we finally have something, and it's the PLM. Okay. I didn't even get in anything. Okay. That might be it for today. I don't think we're gonna get to this is my Hello World. I want to rerun the Hello World one. Okay, look at that. Look at that. It's going, it's going, it's going, it's going. Yeah, what are you doing for the JPEG? Okay, we have to go PMC EMA error. PMC EMA error 1. I need to make my own tutorial. We're gonna make a tutorial that just builds up. Yeah, it looks like we had some type of issue. Standalone, you're on core site, do USB UART1 or 0. I want to see if it works. Oh, what'd you do? Okay. Update. Okay, build. Build finish there. Build. Run. Okay. Hello world. Okay. UART should work. So going back to hop over back here. So what I think is happening is that we don't have the correct configuration for the AIE engines. The AIE engines expect some type of packaging to happen, and I don't something in the system project. Expecting like a Linux. It's trying to run on a Linux setup system. Um, there's no way to turn that off. Yeah, just kill it. Don't try. Uh, it's being annoying, and there's no like has it all packaged up into a xyl bin file. Just yeah, package. No, package build. We tried doing that system PDI. Okay, yeah, let's try that system PDI. Okay, going back up to hello world. The configurations. I want to go to system, nope, system, build, hardware, package, package build, package, system PDI. Use that one. Okay. Let's make sure that no, we want to go here. Sure that support package standalone. Okay, we're on both UARTs. Okay. Anything to rebuild here? Okay, let's try running it. Power cannot reset. Okay. Sure, whatever. Power cycle it. Where's my XSDB window? Right there, yeah. Is it somewhere? Where's the XRTC window? Ah. But okay, let's try running this again. I don't believe you. So that's source tools, Babato, sure. Xilinx in Babato. Settings. This be targets. Okay, you see everything, Ice. You cannot open JTAG port. Okay, maybe it's just it's holding. Yeah, I'm happy. Too many people trying to get to it. Weird. We're done? Oh. Weird. It's okay, maybe it's just because this is running in the background. Have I killed Vitis? Okay, we're gonna kill this. Power cycle the board. Okay, it's happy now. Restart Vitis. Yay for too many steps. What does this Versal board cost? This is around $1,800. I think was the going price was around 1,800. I think the AppNet one's going to be on the cheaper side, probably $600, $800 likely. Ugh. Okay, while we're doing this, let's pop in this guy. Anyways, let's bring in the terminal. Okay. Okay, we began the test. We initialized data. We configured the things. I think it's not allowed to touch the AIE engine. This is like an AIE lockout. Okay. I will go hunt this down. Okay, thank you for joining me. It is too late, way too late. I'm gonna get some sleep and think about this, but we got close enough that we could run it at this stage. We just need to figure out a way to deal with this issue right here. Cool. Okay.